Welcome to the class. In this video, we will learn certain operations on matrices, namely addition of matrices, multiplication of a matrix by a scalar, and difference of two matrices. So let's start. Let A and B be two 2 by 3 matrices. A is equal to 1, 2, 3, 4, 5, 6, and B is equal to root 2, root 3, root 5, root 6, root 7, and root 10. A plus B will be given by one plus root 2 will be the first element, 1 plus root 2, 2 plus root 3, 3 plus root 5, second row 4 plus root 6, 5 plus root 7, 6 plus root 10. This is the matrix A plus B. Corresponding elements of the two matrices will be added. A11 of the first element will be added to A11 of the second element. A12 will be added to A12 of the second matrix. A13 of the first matrix will be added to A13 of the second matrix. Same way, A21 of the first matrix will be added to A21 of the second matrix. A22 of the first matrix will be added to A22 of the second matrix. And lastly, A23 of the first matrix will be added to A23 of the second matrix. So this is the sum of two matrices. Hence the sum of two matrices is a matrix obtained by adding the corresponding elements of the given matrices. For example, if Aij is an element of the matrix A and Bij is an element of matrix B, of course of the same order, before adding two matrices, make sure that both the matrices have the same order. Here the two matrices A and B have the same order m by n, or in our example both the matrices have 2 by 3 order, 2 rows 3 column, first and second also both the matrices have same order, that is 2 by 3. So before adding two matrices you must have both matrices of the same order. If the matrix A is m by n matrix and matrix B is n by n matrix, C will also be an m by m matrix. Cij m by n, and Cij will be given by Aij plus Bij, meaning we have to add the corresponding elements of the two matrices, that is A and B. Now let's add a matrix A to itself. The sum will be obviously 2A. Arbitrary matrix of 2 by 3, say A1, A2, A3, B1, B2, B3. Its order is 2 by 3. So 2A is equal to A plus A. A is A1, A2, A3, B1, B2, B3, and again Same A1, A2, A3, B1, B2, B3. As we have learned that if you add two matrices of the same order, you have to add the corresponding elements. So this A1 will get added to this A1. You will have the first element as A1 plus A1, twice of A1. Similarly, this A2 will be added to this A2. The second element will be 2A2. Similarly, the third element of the first row will be 2A3. In the same fashion, first element of the second row will be B1 plus B1, that is 2B1. Second element of the second row will be 2B2, and third element of the second row will be 2B3. What is this? This is 2 times A. It shows that when we multiply a scalar with a matrix, scalar is the constant number 2. When we multiply a scalar with a matrix, this scalar distributes to each and every element of this matrix. See? This 2 get distributed to every element of the matrix. In general, if A is a matrix of m by n order and K is a scalar, then Ka will be written as K times Aij m by n equal to K into Aij, and this matrix is of the order m by n. Now, let us see what is the negative of a matrix. Negative of a matrix. Negative of a matrix is given by minus A. If A is a matrix, its negative will be written as minus A, and minus A can be written as minus 1 into A. Using the same definition, we will define the difference of two matrices. Let A and B be the two matrices of the same order. Then A minus B can be written as A plus minus 1 times B. What we'll do is, we'll multiply each and every element of matrix B with minus 1, and then we will add the two resulting matrices. Let A be 2, 4, 3, 2, and B be 1, 3, minus 2, 5. So A minus B will be written as 2, 4, 3, 2 minus 1, 3, minus 2, 5, or 2, 4, 3, 2 plus this minus 1 will be absorbed inside the matrix. So it will become minus 1, minus 3, plus 2, minus 5. Now we will add the two matrices as usual. So A11 will be added to A11 of the B. It will be 2 plus minus 1, 4 plus minus 3, 3 plus 2, 2 plus minus 5. The final result is 1, 1, 5 minus 3. This is the answer. In general, if A is Aij of m by n order and B is Bij of m by n order, then A minus B will be given as Aij minus Bij m into n. Now we will learn some properties of addition of matrices. First property is commutative property or commutative law. Commutative law. A plus B is equal to B plus A. Matrix addition is commutative. Second, associative law. Let A, B, C be three matrices of the same order, then A plus B plus C is equal to A plus B plus C. It means that if A, B, C are the three matrices of the same order, so we can add them in any manner, in any order. Either we can add A plus B first and then add C to the sum, or first we add B and C and then we add A to their sum. The result will be same in both the cases. Third property is existence of additive identity. Additive identity. If A be a matrix, then there is a matrix of the same order whose all elements are 0, null matrix of the same order, such that A plus O is equal to O plus A is equal to the matrix itself, where O is called the additive identity. This is called additive identity. Suppose A is 2 by 2 matrix, then O will be null matrix of 2 by 2 of the same order. Last property, the existence of additive inverse. If A is a matrix of m by n order, then there exists a matrix minus of A such that A minus A is equal to O null matrix, or A plus minus of A is equal to O, or minus of A plus A is equal to A, where O is the null matrix. Now let us learn some properties of scalar multiplication of matrices. K is a scalar and A and B are the two matrices of the same order, then K times A plus B will be equal to K times A plus K times B. Second property, let K and L be two scalars, then K plus L times matrix A will be K times L, K times A plus L times A. So these are the two properties of scalar multiplication of a matrix. Now let us solve a problem based on scalar multiplication of a matrix and negative of a vector. Simplify 2 times p minus 2, 5, 4 minus minus 5, 2, 3 and minus 1. So this 2 will get distributed amongst all the elements of the first matrix, and the minus sign will get distributed among all the elements of the second element. of the second matrix. Now the sum will be 6 plus 5 11, minus 4 minus 2 6, 10 minus 3 7, 8 plus 1 9. This much only in this video. In our next video, we'll learn about the multiplication of two matrices. Until then, keep learning. Thank you.